2021 question number 1. Starting off with this question about, well, it says about life on Venus, but really it's about reactions of phosphine. So we are told that phosphine is pH 3, and then we're asked to, number 1, draw the shape of phosphine, which should be pretty much the easiest kind of question you can get. You might not have drawn phosphine, but you definitely would have drawn, so you might not have drawn pH 3, but you definitely would have drawn NH3, and because P and N are in the same group, you can just draw phosphine the way that you would draw ammonia. Now it does say draw the shape, so make sure you show the correct, not ammonia, the correct geometry, which is going to be the exact same as ammonia, which is our trigonal pyramidal geometry. Then we move on, and it says phosphine does not accumulate in Earth's atmosphere as it reacts with oxygen to produce phosphoric acid. The atmosphere of Venus does not contain oxygen. State the oxidation states of phosphorus in phosphine and phosphoric acid. Okay, so oxidation states. Very nice. A couple of free marks for us here. Phosphine and phosphoric acid. So it tells, yeah, it even tells us what phosphoric acid is, so you only need to know that. So hydrogen is going to be +1, which means our phosphorus in phosphine is going to be -3, and then oxygen here is going to be -2. -2 times 4 is -8. I've got +3 from the hydrogens, which means the phosphorus needs to be +5, which obviously shouldn't be very surprising to you because we've oxidised. It's got a lot more oxygen in it, so the phosphorus is going to be oxidised, which means it's going to have a much higher oxidation state. Okay. Then it says write an equation for the reaction of phosphine with oxygen to make phosphoric acid. So reaction of phosphine, pH 3, with oxygen to make phosphoric acid. And there's nothing tricky going on here. You know, sometimes they'll ask you to write a reaction, and they won't have included one of the extra reactants or products, but we can see quite clearly here that this is going to be fine for us. So I've got my phosphorus, I've got my 3 hydrogens, I just need 4 oxygens. So I'm just going to put a 2 in there to balance it. Then there are several methods to produce phosphine that do not require living organisms. These processes do not occur naturally on the Earth's surface because the starting materials are not found or the conditions are not suitable. Write equations for the following. So 3 more equations, okay? I feel like these are all quite straightforward. You know, usually when you're asked to write an equation from a description, it can get a little bit tricky, but these are fairly okay. The reduction of phosphorus trichloride with lithium hydride. So phosphorus trichloride is just going to be PCl3, and lithium hydride is LiH. And we're producing phosphine in each of these, so we always know it's going to be pH 3. So now you do have to work out what the other product is going to be, but it should be fairly clear that if I've used up my phosphorus and my hydrogen, I'm left with lithium and chlorine, and you should be fairly familiar with lithium chloride as a salt. And then we can balance it. So I've got 3 chlorines here, so I'm going to need 3 of those. 3 of my lithium hydrides give me my 3 lithiums and my 3 hydrogens. Fine. And if we want, we can just double check that this is going to give us a reduction. It does say the reduction of phosphorus trichloride. So here, chlorine would be -1, which means phosphorus would be +3. But we've already established that in phosphine it's -3. So we've gone from +3 to -3. So we have indeed reduced it. The hydrolysis of calcium phosphide. Okay, so a little bit more tricky here. So calcium is 2+. Phosphorus, because it's in group 5, same as nitrogen, it's going to be 3-. So it's going to be Ca3P2 plus water, because it's hydrolysis. And then we need to think about what the products of that are going to be. Well, we already know that one of the products must be phosphine, because these are all ways to make phosphine. So my other has to be a calcium salt, and if you're doing hydrolysis, the calcium salt you're going to get, you know, I feel like there's only 2, well there is only 2, because the only elements left over are oxygen and hydrogen, so it's a choice between calcium oxide and calcium hydroxide. But if we're doing hydrolysis, we're going to be forming calcium hydroxide. and then we go ahead and balance it. So I've got 2 phosphoruses here, so I'm going to put a 2 there. I've got 3 calciums here, so I've got a 3 there. Then I've got, how many hydrogens? I've got 6 here, and I've got 6 here, which is 12. So I need a 6 there, and that's done. And then the high temperature disproportionation of phosphorus acid, H3PO3. H3PO3. Now it's high temperature, so it's going to be a decomposition, and it's disproportionation, which means that the oxidation state in one of the products will be higher, and in one it will be lower than the starting material. So the phosphorus here is, well, this is -6, this is +3, so here I'm +3. Alright, so I'm going to make phosphine, pH 3, and I know that that's going to be -3, so it means that the other product must have phosphorus in a higher oxidation state than +3, and I've already worked out that phosphoric acid is +5, so I'm just going to go with phosphoric acid, H3PO4. So I've got my, write that in, that's going to be +5. So I've got my disproportionation, so I've gone from +3 to -3 and +3 to +5. That's what disproportionation means. So I've got, now this is slightly more tricky. So I've got phosphorus, 1 phosphorus here, and I've got phosphorus here, phosphorus here. So the first inclination might be to put a 2 here, and that would look good because then I'd have 6 hydrogens, and I've got 3 + 3 hydrogens here. But if I put a 2 here, that's going to give me 6 oxygens, but I've got 4 oxygens here. So that's not going to work, and there's not really anything I can do with 6 and 4. So what I'm going to do is I'm going to go lowest common multiple, I think is the correct term, which is going to be 3 and 4 is going to be 12. So if I put a 4 here, let's see if this works, and a 3, yeah, that's going to work. So because 4 is 1 more than, if I just look at the phosphoruses, I've got 4 phosphoruses here, and I've got 3 here, but I've got the 1 here that I need. Then I've got 12 hydrogens, I've got 9 + 3 is 12, and I've got my 12 oxygens and my 12 oxygens, so that's fine, done. Then, so this is 1, 2, 3, 4, 5, 6 marks in the bag, and at this point you're thinking this might be the easiest question ever. And then we get to this question, which is a little bit tricky. So it says, another simple molecule often detected in space is methanal. So methanal is this. You're not told the formula of that, so you would need to know that. And then it reacts with phosphine, pH 3, under acidic conditions. So it's going to do it in the presence of sulfuric acid, H2SO4, to give a salt. And the salt has an the cation has a charge of +1, and then I've got an anion, and I don't know what the charge on the anion is. Okay, so let's call it A-, and I don't know what ratio these are in either. So that could be B and that could be C, all right? We want to know what these are. Now it says the formula of the anion and the structure of the cation. So for this one, I just need the formula. For this one, I need the actual structure. Now the 3 pieces of information we were given are, we were given the molar mass of the whole salt. So the whole salt is 406.272. And then we're told that the carbon-13 NMR has only 1 signal. Which means that only one of these can have carbon in it, and all of those carbons that are in it must be the same. And it says the proton NMR has 2 signals, one of which exchanges with D2O. So one of which exchanges with D2O, that piece of information tells us that that signal is for an acidic proton. Because what it means is if you dissolve it in D2O, the acidic proton, you should be familiar with the concept that if I have, let's say for example, HCO OH. This is my acidic proton. What that means is if I'm dissolved it in aqueous solution, that's always coming off, going back on, coming off, coming back on. Okay. Now, if I put it into D2O, it'll come off, and the deuterium will go on, and that's not NMR active. So then that signal will disappear. So this piece of information just tells me that the one of the protons is acidic. So I don't think, for me, this doesn't feel like enough information to be able to solve this question. It's a bit of a reach. And I thought, when I did it, I couldn't really figure it out. I can make a good guess at I think the formula of the anion is reasonably doable. So, because only one of these can have carbon in, one of them is not going to have any carbon in. And it feels like the structure of the anion is either going to be SO4 2 minus, or it's going to be PO4 3 minus. Because anything else would have to have carbon in it. Now, it seems like if the phosphine and the methanol are reacting, then my anion is not going to be from the phosphorus. So that's the only logic I can use to go SO4 2 minus for my anion. And then I've got my cation. So now I know that it's going to be, because this is a 2 minus, it means I'm going to have it's going to be my cation plus, and there's going to be two of them, SO4 2 minus. So that's the formula I'm sort of working with. So now I can do a little bit of maths. I can take 406, which is the mass of my salt overall, and I can take away 32 for sulfur, take away 64 for my 4 oxygens, gives me 310 left over, but I've got 2 of those cations, so I divide by 2. So I'm looking for my mass of my cation is going to be about 155 grams per mole. And it's going to have carbon in it, phosphorus in it, oxygen in it, and hydrogen in it. And it's going to have 1 carbon environment, and it's going to have 2 hydrogen environments, and one of those is acidic. And if it's acidic, it's going to be bonded to oxygen. Now, obviously, I'm working back from the answer at this point, so I know to go through these points of logic. But it feels like, to me, to do this blind, that's a big ask. So, at this point, I start thinking, well, I know that positive cations, the most common positive cation you would learn in school would be NH4+. Okay, and from that, I can sort of go to PH4+. All right, and I can start to think, well, how is my pH3, what's it going to do when it reacts with the methanol? And I don't know for certain, but I assume something like this is going to happen. pH3 is going to come in, it's going to do that, it's going to do that, and that's going to give me something like carbon, oxygen, hydrogen, 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 P, H, H, H. And that would be a positive cation, because now you can see, well, I've got my phosphorus is bonded. It should only be bonded to 3 things. Yeah, it should only be bonded to 3 things. But I've sort of got this dative bond here to an extra hydrogen. Now, this is obviously not the correct answer, because I've got 3 types of hydrogen. I've got hydrogen bonded to the oxygen, hydrogen bonded to the carbon, and hydrogen bonded to the phosphorus. And also, this doesn't satisfy my requirement that it's going to be about 155. All right. So the thing you then have to sort of realize, and this is the leap that, so I could get to here no problem, and then the extra bit is that it then does this reaction again 3 more times. So you get P, now it says draw the structure. So it's going to want some, and it doesn't say, no, it doesn't say, it says draw the shape up here. This says draw the structure, so I think we're okay. So what's going to happen is you're going to end up with CH2OH4 plus, which is going to be POH. So there's 2 hydrogens here. POH, 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 and always with the brackets, don't forget those, like that. And then you'll see that there's 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, but those are all the same, so that's 1 proton signal. And then I've got 1, 2, 3, 4, those are all the same, that's the second proton signal, and that's the acidic one. And then the 1, 2, 3, 4 carbons are all the same. Yeah, so like I say, that's a big ask for me. And interestingly, that's 2 marks. They don't give you any partial credit. It's either you get the 2 marks for that, or you don't get 2 marks. So there it is.